Okay, guys, let us talk about projection. So, what is a projection? The object's view on screen depends on observer. Okay, so if there is a observer, there is a object, and there is a screen. We screen. This is known as projection. If the observer is here and he sees a circular object on a screen, it will look like enlarged because the rays are expanding, or simply the rays, there is an angle between rays. Uh, this sphere, if this is a sphere, it will look like circle in the screen. For our drawing, this screen is our seat. Okay, and we will observe the same object from different perspectives. This is known as basic concept of projection. We'll go through the different types of projection now. uh, if there is a screen, okay, and there is a small cuboid, yeah, okay, so there are infinite line there are line rays or lines, they are coming from infinite sources. So they look parallel to each other. If they look parallel to each other, and there are four rays coming from infinite sources which are perpendicular to the this plane of projection, it will go from this is it will go from this is this bottom is bottom is okay, and it will project in here a rectangle. We know this are perpendicular, these rays are perpendicular to the screen. So this length will be a this length. There will be no change in length or change in scale. Exact dimension will be imprinted on the screen. But if these rays are coming in angle, okay, they are coming parallel to each other, but they are coming in angle. It will touch this point at this point, and this point, and it will like this, okay, like this. Here, these rays are in angle theta with the normal of this plane. Okay, so it will look like this. So if the rays are parallel to each other, this type of projection is known as parallel projection. Inside of parallel projection, there are two kinds of projection like we have seen. If the rays or simply lines are perpendicular to the plane, this is known as orthographic projection. Okay, but if the rays are not perpendicular, the rays are in angle, then this is known as oblique projection. Okay, we will talk more about orthographic projection now. So, orthographic projection. In orthographic projection, we know that right now the lines are perpendicular to the plane. There are different types of orthographic projection based on how we see the object. Okay, so if there is a cuboid, so we know that this orthographic projection, any kind of projection is necessary to completely define. Okay, to completely define the completely define the object. So what is the complete definition of a object? It is if I can replicate or I can know the exact dimension and every dimension. I can know exact dimension and every dimension of the project of the uh, object. So there are two ways to know the every dimension of this object. Okay, the very first way is I see it from here. I project this length on a screen. I project this length and I project this length. I look at it from the multiple views. I multiple views. The second is I look at this object exactly the way I am looking at it. We look at it from mm, multiple views, single view, but we accommodate all views. All views are accommodated. If I look at the multiple views, this type of orthographic projection is known as multi-view projection. Multi-view projection to completely define the object and its dimension. Okay, so if I look at the single view, this is known as axonometric projection. So in multi-view projection, okay, let's talk about the axonometric projection first. So in isometric projection, uh, this angle is 30 degree. Okay, the first angle, second angle, they are 30 degree. In, in second, in axonometric, if this angle is 30 degree, this is known as isometric. This is the type of axonometric. If one angle is 15 degree, then it is known as diametric. And if another angle is one angle is 15 degree but another angle is 45 degree, it is known as trimetric. Okay, so these are three kinds of axonometric views in multi-view projection. Here we looked at different kind different orientation of these lines in axonometric. Three kinds of axonometric views. This orientation, these three lines orientation will be different based on this angle. In multi-view projection, there are different types of view. Okay, let's assume a plane, vertical plane, and the horizontal plane, and observer. Pardon my drawing. It looks very confusing, but it will be clear. So, if object is kept in box, this black is vertical plane. This is a horizontal plane. If and there is an object, and there is an observer. There is an observer in here. There is an object inside a first quadrant. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. uh, it okay, so this there is an object like for example cuboid. Hmm, okay, so very first at first I see the object from here. The front view is projected on vertical plane and the top view is projected on horizontal plane. Vertical plane and this horizontal plane is rotated 90 degree here to represent horizontal plane here. This is my front view, this is my top view. For the left side view, the left side view is project if I, for the left side view of this object, I need to see it from here, and this point of view will imprint the this line, this visible outline in this plane. Okay, so this is our, so if I fold it here, vertical plane, here will be our uh, this plane. Okay, plane 1, and this plane, this outer plane will fold it here, plane 2. So in plane 1 we will look the left side view, and in plane 2 this view we have to look it from here, and this will be right side view. So this is known as first angle projection. Okay, because the object is placed in first quadrant, and there are the imprints, the projection is done in corresponding this plane, this plane, this plane, and this plane, this outer plane, this plane. Okay, so the object, if in first angle, the object lies between plane and observer. Object lies between, observer is here, the plane is here, so plane and observer. Object between plane and observer, and it won't affect if the plane is opaque. If plane is opaque, or we can't see, if you can't see through the plane, it won't affect us because we will be directly looking at object. This is the point of view. Second is third angle projection. What if I place the same object in here, in the third quadrant? Okay, sorry, third quadrant. uh, the object, the plane lie between observer and object, and the plane has to be transparent to see the object, because observer lab is observing the object from here. Okay, in the third angle, okay, in the third angle, if I imprint the image and rotate this plane 90 degree here, I've rotated this from 90 degree here, and this will look like this. So if I rotate from there to here, it will, this view is imprinted there, this view is imprinted there. This is our top view. Yes, this top view is imprinted at the top, and this rotated on this plane, like this side will be coincident to this plane. So on this side there is a top view. So uh, top view will be on the top, on the bottom is this view, this is front view, and of course right side and left side view lies adjacent to the front view, so they will lie below. So for the left side, I need to look at it from the left side. Okay, so it will, so in this third angle projection, the views are extracted, not projected. Yes, extracted, like this is extracted there, this is extracted there. Okay, if the observer is there, this is extracted there, this side is extracted in this side, and this will fold. So this is left side view, and this is right side view. So this kind of convention is known as third angle projection. So general convention or general representation is this. So if this is a object, this is a object of circular cross section, uh, and this is continuously increasing to make it bigger cross section. Okay, so this is my front view, always front view. And if there is a this view written on the left side view, so if the left side view is placed on the left of this front view, and this is its left side view. So this is front view, this is left side view, this is third angle projection. Also, for first angle projection, we have to place right side view and front view. So this, if this is a front view, we have to put the right side view. So this is our right side view. Okay, this is our right side view, and it will be our first angle projection. This is the representation of first angle projection. These are generally presented in our engineering drawing sheets. That's a projection. So this is all about first angle and third angle. For the second angle and fourth angle, the same view will be imprinted on the same plane. For the second angle, like this, uh, if one top view is presented here and projected here in this plane, and this plane is rotated there in this particular plane, so same view will be on this plane. So also similar is the case for fourth angle view. So they are not exactly represented, and they are not exactly useful also. Okay, so this is a multi-view projection, two type of multi-view projection, first angle and third angle. Okay, for the oblique view. Okay, we knew about axonometric, we knew about multi-view. Now we will look at oblique. This is a type of parallel projection, but the rays are not exactly perpendicular to the plane of projection. So there are two kinds of oblique view projection. This is a front view, and the rays are like this. Okay, the rays are like this. So if this represents the full full scale, same scale as of the object. Okay, so this is known as cavalier type of oblique projection if full scale length is presented on this side. If this is a half scale, this is known as receding line. If receding line is exactly the scale of the object, this is known as full scale. This is the half of the object. Receding line, this is our this the front view is same. Then if this is half, then it is known as cabinet type of oblique view projection. Cabinet and cavalier. Cabinet is full scale. Receding line is full scale for cavalier. Receding line is half scale for cabinet. Now, this is the end of parallel projection. We will talk about perspective projection or angular projection. Perspective or simply angular projection. Okay. Okay. There are three types of perspective projection. So, if this is a object here, this is the cuboid, and this is a vanishing point. Okay, sorry. This is a vanishing point here. Then I draw a line from the vanishing point to the every edge, and I define the corner. This is known as single vanishing point. Okay, single vanishing point projection. Single point vanishing projection. Single point vanishing projection, because this this is single vanishing point, and the whole front view is vanished to that point. Single point vanishing. Second, this is also known as parallel perspective. Okay. Second is multiple vanishing point. So there can be two or three. If there is one, there is two, and I have cuboid. This front is vanished on that point, and on first point and second point as well. Now I will make a cuboid out of that. So this is a multiple vanishing point. I can vanish it onto this vanishing point also. This is known as 2 point, 3 point, and similar goes. Okay, this is known as multiple vanishing point. Okay, let's talk about little bit about what is the sectional drawing. I have talked about the cutting plain line in the first video. So to visualize detailing, to make multi-view clear, we use the section view. uh, there are complex part in some of the drawings, and the parts details are necessary. And to observe the part details, there is a section cut, which is like this part is removed, and we observe this part as a front view, this view as a front view. Okay, so I've talked about this in the previous videos. This is a sectional drawing, and why is this the dimensions, part details, multi-view, to make multi-view more clear, to visualize detailing. So another thing is auxiliary view. What is auxiliary view? Auxiliary view is generally generated to calculate the exact length. uh, Suppose, okay, there is a cuboid which has been caught by a plane like this, and we observe the front view of the plane, and this front view looks like this. If I want to calculate the dimension of this cross section, this caught section, I'll use a plane here, and this plane is known as auxiliary plane. And from the auxiliary plane, I will use this this, and I will get the details of this is, or this cotted, not cotted but cut is. So this is the auxiliary view. This view is known as auxiliary view. So I think this is all about the types of projection and views. Thank you.